do the recording. I didn't forget about it this time. Um, okay. So today, if I share my screen, we are going to be talking about popular headers, and at the very end, we're going to briefly touch on cores. Um, and I forgot who, but someone had mentioned cores earlier and was asking when we were going to talk about it. We're going to talk about it today. So there's the answer to that. Um, Real quick though, let's do a really high level review. Where are we? What are we talking about? So the section I've been teaching has been on networking. 2 weeks ago, at the beginning of the week, we started by talking about some networking basics, talking about how computers send information from one computer to another on the internet, and a lot of different concepts like TCP and domain names and ports and IP addresses. And by the end, we were able to use Netcat and have two computers, two terminals communicate with this little protocol I made up. And then after that, we went on to talking about HTTP. So we talked a little bit about what HTTP is, how you structure requests and responses, and we made some requests and responses on our own. We also learned some tools like Postman and curl, and then near the end of the very end of the week, we talked a little bit about fetch. So now kind of coming into this week, you've got a lot of the fundamentals on how network communication in a web developer context tends to work. And this week, we're mostly going to be talking about diving deeper into parts of HTTP and associated tools and technologies that you'll need in order to um, use the tools in technologies we talked about the 2 weeks ago in order to complete your New York Times exercise, excuse me. So the first thing we're going to talk about, kind of that's important, is some of the different headers you can include in requests. And then on top of that, um, some potential edge cases you can run into with cores around making requests in a web browser and how you'd handle that. So before I get into anything here, any questions or sounds good? Okay. So here's a list of the headers we're going to talk about today. Sorry, I need to get my things arranged a bit better here. Okay, there we go. So we're going to talk about content type and accept. These are headers that can be sent in either the request or response for content type, or in just the request for accept. Authorization. So this is a request header. It only goes in when you're sending a request. Location is a response header. Post is a request header. We're talking about custom headers or how that typically works. Those can go with either request or response. And at the very end, we're going to touch on some core stuff with the access control headers, and those are in both the request and response. Okay. So I also should say today is going to be a lot of me talking at you. And we have some exercises to sort of talk a little bit about this, but fundamentally, it's just kind of a lot of information. And there's not a lot of like detailed sort of like exercises we can do. It's more just like stuff you should be aware of. I've tried to kind of come up with some stuff at the end, so we have some things, but I'm just giving you that warning ahead of time. It's going to be a lot of me talking today. So our first header is content type. So content type describes the format of the data contained in the request body. So what you do is when you make a request, some sort of like, for example, like a post request, in the body of that post request, you'll have a bunch of text or a bunch of data. So far, when we've made requests, when we've sent these requests to the server, when they've had bodies, we've just sort of sent like stuff, just like arbitrary characters in the body. And so far, that's been fine. But usually when you communicate with a server, you need to actually tell it what kind of data is in the body. And the reason why is because it's probably going to need to process that data in some way. So a great example, maybe your body contains like HTML. And if you tell the server when you're sending your request that the body contains HTML, it knows, oh, this text is HTML, and I can parse it as HTML and like understand what it means. And we're going to talk about some specific, more specific like things you'd send in the body actually tomorrow. But for now, like some of the things like so example MIME types, I guess I should also define that word. So when you use content type that header, the key of the header, the name of the header is content dash type, and the value, the thing that you sort of put as the value of that header, is what's called a MIME type. And this MIME type, the best way that I've like thought about it for a while is like thinking of it like a file extension. It sort of serves a similar kind of purpose as like it identifies the kind of data in a file. It's just in this case, there's no file involved. It's a network request. So it tends to be file extensions are used for files. MIME types kind of get used in the network context to identify data, but they serve a similar purpose. So the way that MIME types are, okay, I guess I kind of just said this. I'm going to stay over here. So the way that MIME types tend to be structured is you have a bunch of sort of like words that have a slash in between them. So a great example, a MIME type that means arbitrary plain text, effectively what we've been sending so far in all of our requests, that MIME type is text slash plain. So to be like really pedantic, this whole time we've been making requests, anytime we've made a request of the body, we probably should have included the content type text plain like header, just to be like let the server know what we're sending. We omitted it. I wrote my server to be relatively forgiving, so it didn't really matter. But like in the future, that's a thing you probably would want to do. And the reason, I guess I should also talk about like the reason why here too, because you might think, okay, if this endpoint in the server, this request path only accepts one kind of data, why do you have to tell it like what you're sending it? Like, shouldn't it just know? Because it's just that's how the endpoint works. And that's a really good point. But a lot of endpoints, a lot of the power of them is they can actually accept potentially multiple different types of data in the body. So here's an example of that. Let's say you've got an endpoint, a path that you've got set up on your server that you make like a post request to, and in the body, you put the data of an image. Why would you do this? Well, maybe you have on a web page somewhere like an image upload feature or something. So you select your image, you click upload, that has to get uploaded to a server. So it gets put in the body of a request and sent to the server. But the server doesn't know what kind of image that is. It could be a PNG, it could be a JPEG, it could be a GIF, it could be a bunch of other different things. So the way that you tend to indicate that, that's kind of one place where like a content type becomes really important, because if you don't have it, like it's just like arbitrary bytes. The server doesn't know if it's a PNG or a JPEG or whatever. Like you can try to figure it out, but it's probably not going to do a perfect job. Okay, so one last thing about content type. If you don't specify a content type, the default content type that you're supposed to assume based on the specification is this content type application/octet stream. To give you like a little bit of a mental reasoning as to what that means. Like, so network traffic is all done in binary. It's sent over wires and managed by computers. And binary is sort of a series of ones and zeros, and we tend to organize those into bytes when we talk about sizes of things. So byte is 8 bits. So octet stream is like stream of bytes oct 8. I didn't make the rules, it's just how it works. But like that might help it make more sense what that means and not just see it as like a bunch of opaque words. So yeah, that is kind of the general idea of content type. I have included in a slide a link to Wikipedia with a massive list of content types if you want to dig into it and learn more. Most of them are relatively intuitive. that sort of like slash format, there's a lot of sort of like prefixes that go at the beginning. The three most common you'll probably see are text, image, and application. And they all kind of mean have different sort of assumptions. Like image is a bunch of different types of images, text is a bunch of different type of text stuff. Application tends to be like a little bit more like esoteric ones that you wouldn't maybe use quite as much. Although these days, what's esoteric kind of changes over time. Oh, actually, I should also mention one more thing about MIME types. Sorry, I'm a little over the place today. So the reason why MIME types came about in the first place, like what MIME actually stands for, is multi-purpose internet mail extension. And where this actually came out of is with email. So like email, just like HTTP, has a bunch of protocols that back it. And they needed a way that they could define when you're sending an email message what sort of format the email was in. Is it like an HTML email? Is it plain text? Is it something else? So that's kind of like where this originally came from. Like someone came up with this in the context of email for use in that protocol. And then when HTTP started becoming a thing, they sort of like usurped it. They stole it and they put it into HTTP too. So I guess what I'm trying to say is, while we're talking about MIME types in the context of HTTP, they actually are kind of more widely adopted, and they're a relative standard for this sort of like use case of I need to send data over a network, and I need to define what kind of data it is. So I guess I just wanted to bring that up, that like this isn't just a unique HTTP thing. You'll actually see this used in a bunch of different places. Okay, any questions about content type? Okay. So next, we're going to talk about the accept header. So I'm going to suggest in your head you link accept and content type kind of in your head because they're very similar in what they do. Content type defines the type of the data in the request body. It can also be used actually to define the type of the data in the response body. So importantly, you can have it like on either side. You can put it in the request or in the response. Accept is only in the request. And what it's used for is defining the format of the response body. So this is a little bit, they kind of overlap in their usage. I have an example here in a second that I think is going to make it kind of helpful. Just like content type, it uses a MIME type. So same sort of like the slash separated kind of format. And also just like content type, the default value is application octet string. So here's kind of how these interplay. So let's say I'm making a request, post a slash. And in my request, I include a content type text plain header and an accept text HTML header. And I put some text in the body. In that request, what I'm saying to the server is, I am giving you a bunch of plain text. I would like back from you some HTML. And that's what the server gives us. And note, when the server gives us back that response, its content type header is set to text HTML. So in a perfect world, the accept header of the request and the content type header of the response should match. Importantly, they may not always, and that is like a case it's allowed for. Like, imagine you request a type of data the server can't provide. It could give you back a 400, or it could just ignore it. It's kind of like implementation dependent. So as kind of a side-by-side example of a bit of a different approach here, like imagine with my accept header, I requested text plain and not HTML. Same request, just different accept header. The server can be able to look at that and understand, oh, okay, I should send you back plain text instead. And then now our content type header is text plain instead of being text HTML. And we get plain text and other HTML. So in many endpoints, for many servers, like this isn't that critical. It just sort of like just assumes what you give it is the data that you give it, and that's all it is. But it's important to know that this is a thing because sometimes servers require you to include it because they're being kind of pedantic. Oh yeah, I'll paste the slide link in the chat. Sorry about that. And the other reason why is sometimes they accept multiple types of data, and you've got to be able to discriminate properly so that it'll know. Okay, any questions on content type or accept? Okay. Next, we're going to talk about authorization. This is kind of a big one. So the authorization header is a standard place in an HTTP request. You can include information to identify the requester. So what does that mean? Well, if I am making a request to a server, at me, the client, to the server, I might be making a request to get something kind of sensitive. So as an example, maybe I have like a bunch of like messages that I'm in conversations with people. I've got like a bunch of direct message threads going, and I want to make a request to a server and get a list of all those direct message threads. Those are obviously private. Like they're between two people. They shouldn't be the kind of thing where like anyone can see that. And up until now, every request we've made has been like permissionless. It's been anyone can make a request to it and get anything they want. There's been no sort of like, well, I mean, I guess there was that one lockbox one we did that was a little like this. But like in general, we've been making requests that have been to just like open resources. And that's something you do a fair amount. But also, like there are a lot of cases in the real world where data is locked down and not everyone always has access to it. So that's kind of the authorization header is the standards compliant way you tend to handle locking down an endpoint. So the way the authorization header is laid out is you've got two sort of parts and they're space separated. The first part is what's called the scheme, and the second part is the value or I don't know if it has a like what the technical name for it. I've always known it as value, but maybe there's a better name. So what this allows you to do is kind of just like a content type. You're not just defining like your information, like here's my information. You're telling it like the kind of information you're going to give it, which means that potentially you can support multiple different ways of proving who you are. So I guess also take a step back. Like if you have protected information and you want to allow people to access it, in order to do that, you need to somehow like verify who someone is. Like if you only want to allow me to make a request to an endpoint and one of you makes it, like somehow I have to have some way I can like prove to the server that I am me. And that's what this will do. So the scheme might give you like a few different ways you can accomplish that. But at the end of the day, that's really what you're trying to do. Prove that I am who I say I am. A brief aside as well. So this header is called authorization. I think you're going to talk about this in like a few weeks to a month. We're going to have a quick session on like security and talk a little bit about some of the considerations you often have to deal with in building web applications. So I do want to quickly touch on this a little bit because it's important and kind of related to this. So there are these two concepts that are interrelated called authorization and authentication. So this header is called authorization. Confusingly, it kind of gets used for both purposes. Authentication is like just proving that you are who you say you are. Authorization is proving that, okay, you are who you say you are, but do you have access to do the thing you're asking to do? And they're two separate but very related problems. This kind of solves both, and in certain systems, authorization is less important. In other systems, both are very important. So anyway, those like if you're curious about that, like looking up those phrases, authentication, authorization, can do. There's a lot of interesting reading out there, and you'll talk about it in like a month or so anyway. Okay, so how like mechanically, how does this work? I've given you enough like theory crap. How does this actually work? So authorization takes two parameters, the scheme and the value. The scheme can be one of many different values. We're going to briefly touch on two. There are a lot more, though. The two we're going to touch on are basic and bearer. So let's say you wanted to use basic. What you would do is you'd do authorization as your header name with capital A, just like I have written out here. And then your value, the other side of your header, you do basic with a capital B, space, and then what the value that you would use to prove who you are. So, and the same thing with bearer. It's just instead of basic, you do uppercase B bearer. For basic, the way basic auth works, it's sort of like your classic username and password sort of situation. So what you do, actually, real quick, has Max mentioned this thing called base64 encoding to you all before? Does this ring a bell? Okay, cool. We're going to talk about that too then. Okay. How is it best for me to do this? Okay. I think I am going to open up VS Code and get one of those sharing sessions going again. Okay. Live share. Okay. Okay. Cool. Um, Real quick, also, Max just sent me a message and said I need to remind you all that Open Hacks tomorrow, and you should all go. And he just wanted me to say that, remind you all. So I did it. Okay. So if you have, let's say I have a text string, like hello world. And so the way this is represented behind the scenes, every character in this is, well, okay. I'm gonna make an assumption here. We're gonna say just it's like plain text. There's nothing, just like A through Z characters. Every every character in this is a byte. So 8 bits, and there's sort of a lookup table between every type of character and then a series of ones and zeros to make up that byte. So what you get is this series of bytes in a row that are sort of like it's when you a computer looks at this, it sort of like sees a byte string that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bytes long. And when it wants to like understand that, it like takes each byte and does the lookup, and it's like, oh, okay, that's H, oh, that's E, oh, that's L, L, O, and goes all the way down. There are other ways, though, you can encode text. And one of the kind of more popular ones, or I guess or I guess I should say there's other ways you can encode text, but one of the downsides to encoding text in this way that I just described is if you have characters that like you have a series of bytes and you're like trying to feed that in to display that as text, and that series of bytes aren't able to do that lookup properly, then you won't actually be able to see characters that make any sense. So in this case, the reason why you see hello world here is because, I mean, I typed it out, but like if you imagine the bytes behind the scenes, each one corresponds to a letter. But if one doesn't correspond to a letter, you're just going to see like you're going to kind of see like garbage. Like it doesn't really know how to do that lookup properly. And that's a real problem because if you took that series of bytes and you did something like copy that to your clipboard and pasted it to somebody, and then someone else like copied it to their clipboard, like the text formatting is going to get all messed up, and the underlying bytes in that were being sent are going to get lost. And a big part of why that is because like a lot of systems will be like, oh, these are garbage bytes. I'm just going to get rid of those. Those aren't useful. Or it'll be like, oh, I think I know what you mean. I think you mean this one. It'll try to correct it. And what this means is text like this, it makes a lot of sense if you're sending relatively standard English character messages. It doesn't work so well if you're doing something like sending arbitrary bytes back and forth from one person to another person. Because of that, there are ways of encoding these bytes, just arbitrary bytes, that are, I guess I would say, like, allow you to keep those properties of copying and pasting them back and forth and sending them from one person to another. And the way that it does that is by changing how that lookup works. So instead of doing the lookup with what's called ASCII, I'm going to quickly go ASCII table. I mean, I'm assuming probably most of you have encountered this before. If not, it's good to know that it exists. But so you've got something like this, where this is sort of like the lookup and kind of how that works. But like there's a lot of bytes missing in this. So there are another type of encoding called base 64. Guessing I can probably find. Yeah. So importantly, with ASCII, it's sort of like trying to think of the best way to explain this. With ASCII, you run into problems with that encoding sometimes not working properly with arbitrary bytes. With base 64, you don't run into that problem. I think I'm going to leave it there just because the more I'm getting this, the more I'm realizing that I have to get into a lot of stuff to be able to explain this properly. And I don't know if I have the time right now to be able to do that. So I think I'm just going to leave it there and say like that's a problem base 64 solves, being able to encode bytes that don't easily like display as text. And why is this important? Like, how does this relate at all to this authorization header thing? Well, the reason why is if you're making a request and you're using the basic scheme for auth, they've built it in a really like forward-looking way where you may not have like credentials, like a username and password that are text like encodable. They might just be like arbitrary binary. In practice, does this ever happen? No, not really. But they've built it in that sort of way to have that like forward-looking capability. So in the future, that would be pretty easy to handle. Because of this, it means that if you want to use basic auth, you have to take your username and password and you have to encode them with base 64 before you can give them to the header. So what this does is it means if either of your username and password are not ASCII printable text, you can still include it in your header, and it makes it easy to copy and paste, and you're not going to run into issues where like you're going to be trying to send bytes that aren't easily represented as text. So as a quick example to show you what this kind of looks like, there is a function in the browser called B2A. and a corresponding one called A2B. And I will admit, I always forget which one goes which way. One of them encodes from text to base64, and one of them decodes from base64 to text. So we're going to try it and just see if which one it is. Nope, it's the other one. Okay, yeah. So with ASCII, you have just these like what ASCII strings normally look like are just like text as you'd expect it. Base64 strings, the characters you'll see in them are A through Z, all lowercase, A through Z, all uppercase, plus and equals. And if you do the mental math and think about it, so you've got all lowercase letters, all uppercase letters, so 26 plus 26, I think. Wait, 64. Wait a second. I mean, whatever. I can't do math. What it ends up being is you have all of the oh, and numbers. That's what I'm missing. Yeah. So 26 plus 26 plus 10 plus 2. Yeah, there we go. So 26 lowercase letters, 26 uppercase letters, numbers, and plus and equals. Between all those, you have 64 possible combinations per character. And that's sort of where the name base64 comes from. This is all to say that if you want to use basic auth, the way you do it is you take your username and then you do a colon and then your password. And then you encode that with base64. And this thing here becomes the value authorization. Like this, you would put in your header. So that's what you'd put there. And it would sort of be able to, like, it would, on the server side, you'd take that, you decode it, and you'd get out this username colon password thing. And once you do that, you would be like, oh, okay, that's my username and password, and you're good. One last thing I want to say about base64, just to make it unambiguously clear, base64 is not encryption. Like, it looks all like goofy and messed up. So I have this string right here. If I use the other function, so instead of B to A, I do A to B, and I give it this, I get this back right out. So like, if you have base64 string, it is trivial to decode. Like, it's just sort of like doing the reverse of the what it did to create it. There's no sort of like security that base64 adds. It's purely for just like changing how text is encoded so that you can represent binary text or binary data as like printable text. Okay, so that's high level basic auth. I'm not really going too in depth here on this. I mean, we're talking about base64 a bit. I kind of got a bit down a rabbit hole more than I want to do there. But basic auth is good to know it exists. It's not something you're going to run into like a ton in comparison to the other auth mechanism we're going to talk about. Mostly though, I want to expose you to it. I want to use it as a chance to talk a little bit about base64, and you will see it at some point. So like, I want you to know about it. So I want you to know about like another auth mechanism other than just basic or bearer auth. So bearer auth, this is the other one. Bearer auth uses this thing called a token or a bearer token. And that's what goes in the value part of your header. So with bearer auth, it goes authorization, bearer with an uppercase B, and then your value, which is a token. So I'd imagine probably some of you have heard the term token before, or some of you probably haven't, but a token is a really important concept in this whole like authorization, authentication sphere. I'm going to talk about a little bit here, but in the security section, you're going to talk about it a lot more than I'm going to go into it now. So a token is a unique identifier that's pre-generated by the folks that run the server that is secret and belongs only to you. And the idea with a token is you treat it as a private credential that only you own. And when you make a request and include it, the server can assume the only person who has that token is you. So therefore, if you're including it in the request, you must be the one making the request. So effectively, think of it kind of like a driver's license. if you get pulled over and you give that driver's license to the police officer, like it's proving you are who you say you are on the driver's license because you're the only person who should have that license. And if you look like the picture of the person on the license, but you're not actually that person, and like you're not suspicious, like how are they going to know? Like I guess they could like fingerprint you or something. I don't know. But like in practice, like the way that they know who you are is because you have that driver's license and no one else should have it. That's the idea with the token. So we're later this week going to be doing some things that involve them. We're going to be generating some. Keep in mind they are secret. So a token is not something you want to like send to your friend or publish on social media. In fact, when tokens get exposed, typically the course of action is you do what's called revoking them. So that'd be like taking your driver's license, shredding it, and going to the DMV and getting a new one. And the idea is because like now all of a sudden your token's no longer private. It doesn't serve its purpose anymore. And the only way it can serve its purpose is if it's private. Okay, so let's talk a little bit about some uses for tokens and how these kind of fit into this authorization concept. So I guess we talked about like authentication and authorization. So you can probably kind of see with the driver's license example, like how that's important. There's a couple other places though that tokens come into play where they're used. Rate limiting is an interesting one. So let's say you have a API server, something someone's running online, and they are offering like a free service, but they want to make sure that people aren't going to abuse their service. So the way they deal with that is they will let you generate a token, and think of it like they're giving out like driver's licenses to everybody. And when you make a request, you have to give them like let them see your license to be like, oh, okay, I'm this person. And by doing it that way, it means that they can now track how many requests you make. So let's say you make like 10 requests, and then you wait a second, you make 10 more requests, and you wait a second, you make 10 more requests. Like you're making a lot of requests as compared to someone who's like maybe making a request an hour. And like you're kind of taking more than your fair share of the computing resources. So with rate limiting, the idea is you can use this token value to be like, oh, you've made so many requests. Okay, we're cutting you off until some point in the future when you can make requests again. You've made too many. Come back later. So typically you'll get something like a 429 conflict or something like that in response. Or I think that's what it is. 409, 429, I forget. Something like that. But like there are, I guess what I'm trying to say is there are like, while the thing you're going to run into most is kind of the authorization, authentication, like that pure use case, there are other sort of associated things that they're used for. So even if like a service isn't requiring like accounts, they might still have them for like, for example, rate limiting. Okay. So here's kind of tends to be how this works. I'd imagine this is probably pretty straightforward for folks. Like authorization header, bearer, your token, and that's included in the request. So you can include that in the request. The server receives that, looks at the token. It's like, is this a valid token? Is this look all good? Is the driver's license good? If it is, then it accomplishes the request, sends you back a 200. Everything's great. But on the other hand, if you sent a bad token, you can get kind of a number of different responses here, but they all tend to be 400s of some sort. Probably the most common would be a 401 unauthorized, which just means like, sorry, bud, you didn't include the right credentials. Try again. So that's we have an exercise later. We're going to do a thing with authorization. So we're going to touch on this a bunch of times. I really just want to expose you to it now as like this is a thing. It's going to keep coming up, but this is sort of our first touch on it. Okay. I realize I'm doing a lot of talking, and usually that doesn't go over so well, but any questions on authorization? Okay. few more to get through, and then we have some exercises. Yes. Oh, I do want to mention. So everything I'm talking about here is like best practice standards kind of stuff. Sometimes people don't put tokens in the authorization header. Sometimes they'll just have like a query parameter called token or something, and they chuck it in there. Sometimes you'll put it in the body. Like, people do some weird stuff. And while the whole authorization thing is like how it should work, it doesn't always work that way. I just want to like make that known that it's not always like people don't always follow the rules. Okay. Next, location. Somebody 2 weeks ago, I think, asked me the question of, okay, we talked about 200s, 400s, and 500s. What do the 300s do? And I gave a really bad answer. I was sort of like, we're going to talk about this later. But now we're going to talk about it. So 300s, there's a number of different things in there. But the most important 300s you should know about are 301, 302, 307, and 308. And these are what are called redirects. So to explain kind of what redirects are, you got to think about kind of where the web came from. So going back sort of to like the early days of the internet, HTTP 1.0, way back in the early days. The whole idea of the web is you have a bunch of documents that are all sort of like on the internet. And HTTP is a protocol that lets you get an update and change those documents. So a document could be an HTML page, which is kind of one of the most common use cases you run into these days. But it could be other things too, like an image, like some sort of presentation, a PDF. Because though these where these documents live, they're supposed to be like long-term, long-living resources. The people who made HTTP wanted to account for the fact that like as time goes on, you might just choose to change where something lives. So let's say you have like an image that's on example.com/test/image.png. And you put it there, and then a bunch of people link to your image on their own websites, and they put in their image tag, image src equals example.com/test/image.png. They've got that hard coded on their website. And then you come along and you think, I want to move that image. I want to put it in the root instead. Like, I just want to put it on like example.com/image.png. So get rid of the test in there. Okay, so you do that. And after you make that change, you delete the image, the other person's website breaks. That's not great. And you probably want to avoid that happening. So what redirects allow you to do is allow you to, in a response to an HTTP request, return a response that tells the client there's nothing here, but actually to get what you want to get, you should instead make another request to another URL. This is like, you should redirect where you're making your request to. So as an example, this is kind of how a redirect might go down. So you make your first request to example.com, the /first, and you get back a response, 301 moved permanently. And a header you get back whenever you have a 301, 302, 307, or 308, you'll get back a location header. This location header says, actually, this is where the resource you're looking for is located. So what'll happen is well-behaved clients will take that response, will pull out that location header, and will effectively make a second request to that new location header and return the response of that second request, kind of just as if that first request, like that's what you got back. So what this means is, going back to our initial example, if that person that did like the /test/image.png, if they made /test/image.png, if they made that return back like a 301, then now the person who had that URL on their web page, that would still work. And like things wouldn't break. So the whole idea with redirects and 301s, 302s, and all that is to avoid breaking hard-coded links on the web. and it works relatively well. It's a strategy that's like gone well. The so I guess I should briefly touch on kind of like 301, 302, 307, 308. I've touched on a bunch of these. So 301 is moved permanently. What that means is the location header you're getting back in the response, that is where that resource now lives permanently. Like it's been moved, it's no longer there. 302 is 302 found. That means the thing you're looking for is moved, but it's not a permanent move. It'll eventually be back at its original location. And the reason why it's an important semantic difference is because, and we're going to talk about this later this week, HTTP relies really heavily on caching data. So doing things like if you make a GET request and you get back certain data, and you make another GET request of the same like query parameters, same headers, same everything, the web browser can avoid making that secondary request again. It can just use the data it got back from the first request. And that's kind of nice. It makes things a lot faster. Of course, there are trade-offs, but if you know how to work the system, it can be a big performance win. So 301, what that does is effectively updates the cache locally so that the old URL points to the new thing permanently. So that like if you make another request to the original thing, it won't remake the request because it just knows it's a redirect. And the 302 doesn't update the cache. So if you have data there that's going to come back, like it's not a permanent redirect, it'll eventually be back there again. You do a 302 so that like when the redirect happens, it won't cache that. And then when the file goes back there again, so it sort of gets fixed, it'll work again. So it's a subtle semantic difference, but it's kind of important to how the web works, is why it's been established. 307 and 308, same kind of idea, same sort of difference. It's just there's some extra stuff that 307 and 308 does that kind of fixes some problems with some of the early implementations of 301 and 302. But like fundamentally, same kind of idea. Okay, so really what you should take away from this is like the concept of redirects, what they do, why they're important. So if you move stuff, you need to be able to ensure that old links don't break. And that 301 and 302, if you see those mean redirect. Okay. Any questions on the location header, 301, 302, any of that stuff?
Yeah. So you should so when you ever like discover like 304 like not modifying, what would you like do about that part?
Yeah. So I chose my words carefully before, and I probably should have called out that I chose them carefully. So not every 300 code has to do with redirects. 304 not modified. What that means is your web browser has made that request before, and instead of giving you back the regular version, it's giving you back a cached version. So that cache I was talking about, like if you think of it as like a big sort of like JavaScript object in your head, where the key is like the request and the value is the response, and the request contains like your body, your headers, your URL, your query parameters, all that stuff. What you can do is like you can look it up in there and get the response, and if you do things right, that's fine. When you do that, when that sort of cache hit happens, you get back a 304 and not a 200 usually. So that's kind of, I guess, that's your question. Like that's what that means. Cool.
Yeah, I was thinking like when you like go to Google and like let's say like Bootstrap for example, like Google have like an older version like Bootstrap and you click on it and then you go to the website and Bootstrap like, oh well, we have a new version and just click here to go to the new version. Would that count as a not modified or
Um, I think it ends up being usually a lot lower level than that. So here's a good example. Let's say you've got a web page where you've got a really big image. image. When I'm saying really big, I'm talking about maybe like 100 megabytes, something crazy like that. So what you could do if you were to like write your own web browser, if you think sort of like what you would do in that case, you'd download your index.html, you'd look at it and you'd be like, oh, okay, there's an image in there, image src. And you'd be like, okay, so that image src, there's a URL there. So you take that URL, you make another request to that, you go get your really big image, and then you wait as it comes byte by byte, slowly over the wire, taking a long time. The whole time the user's on that web page looking, you got a little loading spinner going, and they're like, the user's like, what the heck? Why is this page taking forever? And then eventually it loads, and then they refresh their page, and then the same thing happens. So the loading spinner there forever. So the idea with like a 304 is because you make that request, you get back that response, the image in it, and you cache that, you save that to the computer. And because it's a really big image, now the next time you make that request, you don't have to worry about fetching it again. You can just use cache data. So that means instead of having to download like hundreds of megabytes, you just have access to it instantly. So that tends to be where it gets used, like, or where I guess the real wins come with it, where you have these responses that take a very long time to come back, either because the server is really slow or because it's really large. And caching can sort of like speed that up considerably. Cool. Okay. I'm assuming I answered your question there. Cool. Okay. Um, any other questions? Okay. Next header. The next header we're going to talk about is the host header. And the host header, at least initially, might look a little bit confusing. So the host header will give you the domain name you used when you made the request to the server. So in this case, like, let's say I'm making a request to example.com on port 80. The host header will contain the value example.com. You might be wondering, why is this useful? Like, you're just duplicating information. You've got it there, you've got it there. What's the point? Well, I would say back to that, not exactly. It's a little bit more nuanced than that. So if you think back to when we talked about networking originally, we talked about how DNS works and how DNS is this big lookup table of like domain names to IP addresses. So what happens behind the scenes is when your client computer wants to connect to a server, it will first take that domain name, look up its corresponding IP address, and then make a request to that IP address. So like behind the scenes, this is actually what's going on. Even if you do ncexample.com, like it's actually doing that secondary step. Because of that, the host name never actually makes its way into the actual request of the server, only the IP address. So this is often not that important. It's kind of a small difference, but there's one place where it actually is really important. And that's if you want to have one server that serves multiple websites. So if you think about this, you have one computer, physical computer, that's got a port open, port 80, got multiple people sending it requests. What that kind of looks like is something like this. You're like, there's a request coming in from some IP on port 80. There's another request coming in from some IP on port 80. You have no way without that host header of knowing actually where they're visiting. Like, if this, let's say the server hosts hackupstate.com and also careersandcode.org, like, you have no way to know, is it, which website are they visiting? So it's actually not duplicate information at all. It's actually really, really important. And if you don't have it, you don't really have a good way of knowing for sure, like where someone's coming from. In fact, it's so critical that a lot of websites, if you don't include it, just will give you back a 400 and be like, this is invalid. Like we don't know what you're doing here. With what I've written, the server we've been talking to so far, I've made it very loose. It doesn't really care. So like, it's not been a problem so far. but I'm mentioning it because we're going to start to actually talk with some real servers, and that's when it really, like, including some of these headers becomes important. You can't get away with being lazy anymore. Okay, any questions on the host header? Okay, last one. Custom headers. So if you have a need to include headers that are not ones we've talked about so far, or I mean, of course, there's more we haven't covered, but sort of like non-standard headers, you want to include your own custom metadata along with the request. You can do that. You can. There's no reason why you can't just make up a name. You can take your header and you can like call it like my, like uppercase M, my, actually I'll type it out. Like you could do like my cool header with like my value. There's no reason you can't do that. However, it's not encouraged that you do this. This is kind of like an anti-pattern. And the reason why is think sort of through how like the future might go. Imagine you make this header called my cool header, and then someone at the HTTP folks, they're like, wait a second, we want to introduce a new version of HTTP, has a new header. It's like a standard header called my cool header. All of a sudden now, the server you're sending the request to, if it's using a newer version of HTTP, will think you're sending the standardized header and not your custom header. So effectively, what that means is the server is like not sure what you mean and it's ambiguous, and it's just a situation that would be like good to avoid. So in the HTTP specification, what they've said is if you want to make a custom header you include in a request, what you should do by convention is start it with an uppercase X. Who defined that? I have no idea. There's probably some good reason why they picked that, but it's just how it is. So if you do like this, X my cool header, that's what you're supposed to do. So why, like, how does it solve the problem? Well, HTTP folks have said they will never create a header that's defined in the HTTP specification that starts with an X. So because they won't ever put anything in that namespace, they've sort of reserved it for like anyone who wants to do anything custom, they can put stuff there. We're not going to touch it. So it sort of works around this problem. Long story short, if you ever want to make a custom header, start with an X dash. It seems weird, but like it's just what you should do to sort of follow the conventions and make sure you don't end up inadvertently breaking something in the future. Okay. Those are all the headers I want to talk about today. So before we go into some exercises, anybody have any questions for me on anything we talked about or I talked about? Okay. So these headers are kind of hard to write like exercises for because they're kind of somewhat abstract. Like they're going to kind of like the only way you're going to get like use them is by just like making requests in real life. So I've got two quick exercises here that are a little bit contrived, but like I think are probably just like good sort of reviews. We're going to go through those. And then after that, we're probably going to take our break. And then we're going to talk about cores. Know that later in the week, we're going to be making a bunch of requests and using these headers. So like this isn't just something we're talking about today, we're never going to talk about again. It's going to keep coming up. Okay, so here is where we're going to start. So for all these, I'd like you to do all these in Postman. I think this first one we might do together, just sort of like give it a like get everyone warmed up a little bit. This first one has like two parts to it. So what we're going to do here, we're going to sort of like try making an authenticated request, like a real authenticated request. So the way we're going to do that is we're going to generate a token to start with. And the way we're going to generate a token is we're going to make a request to the server. And then secondly, we're going to then include that token in another request to the server. and then hopefully the request will work. So typically, in a lot of systems, this first request wouldn't actually be a request. It would be like you go to a web dashboard, you click some buttons, and you generate like a token in their web app. But sometimes it is a request, and in this case, it's going to be one, so I want you to do a bit of practice here. So, okay, so I'm going to get Postman opened up. You all should get it opened up too if you can. Okay. So we need to make a request to this endpoint here to generate our token. So I'm going to just pull out some stuff I see here. Method post. Okay, that's pretty easy. URL. So our URL starts with a protocol, port 80. So we're on HTTP. So HTTP://. Then our host name, careers in code.xyz. Then our path, tokens. Okay, so got our host name, got our port taken care of, method taken care of, path, no body, no custom headers. So it looks like this is all we got to do. We just got to do a post to careersincode.xyz/tokens. So I'm going to click send. Okay. So I would love like all of you to go through and do this. You should get back in a response to 201. You're going to get some message back that looks like this. Your token was created. It is this. This is your token. You should keep this secret. Now, in this case, it doesn't really matter. These tokens don't really do anything real, but as good practice, like don't share it. Yeah, I see a few people are doing the thumbs up. If you could, once you get this done, if you could give me a thumbs up just so I can keep an eye on how people are doing. Okay. Okay, I'm seeing a bunch of thumbs up. I'm going to keep moving forward then. So if you got your token, take that, keep that safe. I typically I'll say like copy to my clipboard. Okay, now we're going to make another request. This one though, I want you to do it fully on your own. So you're going to make same sort of everything with the request, but this time you're going to be making a get to /protected resource using an authorization header with the token you've gotten as a bearer token. Now, do you want to call out? I'm not giving you the full specification here. It's kind of on purpose. So far, I've been giving you a lot of like, here's exactly what the request you need to make. From this point forward, I'm going to be giving you a little bit less detail because this is actually how it is in the real world. You have to sort of intuit some stuff. So we're making a request the same domain name, same port, all that stuff's the same, but there's just some key differences here. And if you need to look back at the slide to see how that authorization header gets structured, it's a bearer token, and you just got your token. So give that a shot. I'm gonna give you a few minutes. Keep the thumbs up thing that I think is working pretty well. So give me the thumbs up when you're done, or if you reach out if you want some help. So Joe asked, what's the header supposed to be? So I'm going to go back over here up to the actually, here we go. So we need to for this one we're going to have to include an authorization header. So here's an example of what that might look like. I'll take this and I'll the error message I received, your token was not found in the server's registry. Take a look at the status code you got back from the server. If you got back like a 400 or something like that, that probably means there's something not quite right with your request. If you got back a 500, that's probably a bigger problem. I'm guessing you probably didn't, but it sounds like to me from that response, your token that you sent to the server was invalid. So it was able to find the token in what you sent, but just the actual value that it pulled out and tried to look up, couldn't find it. Yep, error 403. So starts with a 4. I'll give everybody a few more minutes, unless you want me to go through it, but okay. So for this one, you can make a GET request. So we got that part. For the URL, the same one we made before. We've got a lot of the same parts. So we're making a HTTP request to careersincode.xyz. This time, though, we've got a different path. Protected restore. We also, though, need to include that authorization header. So to do that, I'm going to go to headers here. I'm going to add that header. So the name, which you'll see actually if you start to use some of the standardized headers, Postman will autocomplete for you because it knows what you're doing. And the value, so going back to the slide, looking at the reference here, those authorization, bearer, your token. So authorization, bearer, space, and then I'm going to paste my token. Oh, there. Okay. That should be everything I need. So I'm going to make that request. There we go. It says you specified a valid token. I got back a 200. That's great. So a few common sort of failure cases you can run into here. Let's say this token is like not right. This is sort of where you run into that your token was not found in the server's registry problem. So you need to make sure that your token here is correct. And like also if you include that scheme, it's not going to work right because it's going to be like you didn't specify it's getting confused effectively. It can't find that scheme, so it's getting lost. If you forget that header altogether, same kind of thing. One thing I will just quickly mention, mostly for anyone who watches this later if it's recorded, is that the way that I've built this behind the scenes, I've not stored this in the most intelligent way. At some point, probably in like the next month, they'll end up restarting the server for some reason, and all the tokens that are in there will get lost. So like, if you have a token now and you're saving it, you try to use it in like a month, it might not work. You might need to make a new one. Doesn't matter anyone right now. This is more just for the recording for posterity. So yeah, that is very high level how that is very high level how the authorization header tends to get used most of the time. Something like this. I'm glad it's working for you now. Any questions anybody has on this? Okay. Okay. So, remember last or 2 weeks ago, I mentioned how there was at one point we're going to use that feature in Postman where you can like upload in the body like binary and you can like select a file. This is where we're going to use that. This is like the one time we're going to use it. It's not a very common use case, but I needed something, and that's kind of what seemed to make sense for this kind of exercise. So I have an endpoint on the careers in code that XYZ server called image upload, image-upload. It's a post request. I would like you to upload an image to this endpoint. This image should either be a JPEG or a PNG image. If you don't have anything around, you can just sort of like go like smiley face or something and find yourself an image. Just go like save image as and save it into your downloads or something. So we've got that. Importantly, it's a PNG, so that's good. That's what we need. So doesn't matter what image you use. The only thing I would say is just for the kindness of my server, don't pick a like 100 megabyte image, please. I actually think it probably would reject that, but I don't want to eat my words in a second when you do that and it takes it down for everybody. Yeah, so find an image. I want you to upload it using Postman, that body sort of binary feature. Um, and the kind of the real part of this exercise that I'm hoping to test is like, I want you to set your content type header to be the content type of the image you're uploading. So because you're either going to be using a PNG or a JPEG, I've given you the content types for these literally here. You can also look them up online. If you look up like PNG content type or PNG MIME type, you're going to find like it's just right there. Um, so make that request, send it. I want you to make sure you get a 200 back. So give it a shot. I'll give you a few minutes. Okay. I think most people have had success. If anyone wants a few more minutes, let me know, but otherwise I'm tempted to just go through it. Okay, let's go through it. So, got my postman out here. So I need to make a post request. I think it's with a post. Yeah, post to careers encoded XYZ slash image upload. Need to include a binary body, so I'll go do that and I'll select it. Okay, now I got to include my content type. So I'm going to go over here in the headers. I'm going to go to content type. See, it'll auto-complete it because it knows it's a standardized header. And then my content type, because I uploaded a PNG image, is image/PNG. So then I'm going to click send. Image successfully received. Thanks. That's good. So that's about it. Not the nothing really all that adventurous, but I just want to give you a chance to give that content type header out for a try there. Okay. So those are the only two exercises I have for this header stuff. I think now we'll probably take our break, and then when we get back, we will talk a little bit about cores, which will be exciting. Oh, I got to do come up with the attendance word. Gosh, the trickiest thing of the class. Um, yeah, I like it. Endpoint. Let's do it. Endpoint is the word. Um, so give that a set. Do the form with that for attendance. I think probably we'll get back at 7:30. I think it sounds good. And then once we get back, we'll talk a little bit about cores, and then we'll be done for the day. So we'll be back at 7:30, and see you folks then. Zoom the recording. Can't forget about that. And okay. So unfortunately, we got a bit more of me just talking here. We're going to spend the rest of the class talking about this thing called cores. So somebody had mentioned earlier, had asked me when we were going to talk about this, talking about it now. CORS it's an acronym. It stands for Cross-Origin Resource Sharing. And CORS is a browser security feature. So importantly, you will only encounter this in a web browser. You won't encounter this if you make a request with Postman or with curl, only with like fetch in a web browser, or just like in a web browser in general. CORS is also something every web developer has a very negative relationship with. And you might think I'm exaggerating a little bit. Like, I have yet to meet an engineer that writes software that says they like CORS. It is just a constant pain in the ass. Like, it really is. And I think as we get into this, you might kind of start to see why. But that's sort of an overview. These are the kind of messages that you will see when you deal with CORS. Something that says XML HTTP request cannot load some URL. No access control allow origin. That in particular, that phrase, that header name, you see access control, something like that, your brain should go CORS. That's sort of like the signal. No access control allow origin header is present on the requested resource. So CORS Yes, I restarted the recording. What CORS does is it provides a really important layer of web security. In order to explain, though, what it does and like why it's important, I have to talk a little bit about some important stuff we've skipped over in the context of like web security. The first thing is this concept of same origin versus cross-origin requests. So here, cross-origin resource sharing. I need to kind of break down like what that actually means. So there are two types of JavaScript-initiated HTTP requests. Also, just in general in the browser, the requests that get made by the web browser kind of falls into these two categories. What's called a same origin request and a cross origin request. So a same origin request is a request that's made to the same domain name as the executing JavaScript. So let's say you're on example.com and you make a request to example.com/test. That's a same origin request, probably. I'm gonna be putting asterisks all throughout this, but like, sorry, it's just like all this stuff. There's so many little exceptions. Generally that'll be a same origin request. A cross origin request is if you were like on example.com and you're making a request to like careersincode.xyz or like hackupstate.com. So like you are making a request to a completely different domain name. Also just want to call out like subdomains, also like completely different domain name. So like it is that like domain part of the URL that has to sort of be the same. That's the most important requirement for a same origin request. So by default, in a web browser, this is a really important point, you can only make same origin requests. So I'm going to say it one more time. It's that important. You can only, by default, in a web browser, make same origin requests. So if you are on example.com and you want to make a request to hackupstate.com, by default, you cannot do that. And let me prove it to you here. So I've got a little like fetch here. I'm going to go to careersincode.xyz. This is sort of I've got a little index.html that serves up here, but I'm sort of on careersincode.xyz. I'm going to try to make a request to careersincode.org. You're going to see we get that CORS error that I mentioned before. So in particular, the thing that I'm looking at that makes me say CORS, I mean, it does say CORS policy there, which is kind of a giveaway, but also access control allow origin. Okay, so now that I proved to you that CORS exists and that like you can only make same origin requests by default, why is that the case? Like, it seems like that would be a really annoying limitation. If you put a server out there on the internet, no one could make a request to it by default. There's a few reasons, but I'm going to walk through one that's pretty easy to think through that would be like a pretty bad thing if you could do. So imagine you work at Google and you're in charge of developing Gmail. So you have this web application you're building that you're deploying, you're putting up on the internet under gmail.com. So anyone who goes to gmail.com, they make their GET request to /, they get back the application, they can interact with it. In that application, you see a list of all your email messages. The way that's being gotten is it's making a request to the server to maybe like a GET to like /messages or something to get like a list of all your messages. Or I'm going to say actually /emails to match with my convention here. And then maybe you've got like a way you can delete messages. You've got a little like delete button. And if someone clicks that, like what that does, that makes a request to the server to say like a delete to delete an email. And that's all well and great. And you can use the application and it works really well in your web browser and you're all pleased with your You can like delete as many as you want. You get back a 200 for every request. But importantly, in this sort of paradigm, putting aside cores for a second, sort of like if you had this as a thing you could do, imagine that instead of Gmail making that request when you click that delete button, that like delete request, instead you had someone else maliciously making that request on your behalf. So what this could be is, imagine you went to some other website. It could be like a phishing website. It could be like some, it could be like an ad that's embedded in another website that has like a malicious button on it. And somehow they're able to socially engineer you into clicking that button. What that will do is that could make a request to delete that email. And all of a sudden, that other web page has interacted with Gmail on your behalf and done something destructive. It's like destroyed something, which isn't good. Especially because like something like deleting, you can't really necessarily recover that. So this sort of like attack, this sort of like vulnerability here, this idea where someone else could like forge a request on your behalf, because like from the server's end, it just knows the request is coming from your IP address. It doesn't know like what tab and like where that's coming from. I mean, the host header is going to be in there, but that's going to be the domain it's requesting to. That's not like the person who's actually like sending it in from the web browser. So this sort of attack, this sort of vulnerability has a name, a CSRF, cross-site request forgery. This is a pretty common sort of like attack vector that you need to protect against on the web. If you are using fetch and sort of like more modern mechanisms for building applications, cores is sort of one of your primary ways of protecting against this. There are sort of older technologies in the web that you can use that don't have this necessarily protected from, and you have to sort of work around it in other ways. But like this primarily, this kind of problem is like the kind of thing cores is meant to solve. Because I guess before I keep going, any questions on that? Does that make sense? Cool. Okay, so because cores exist, you can't do this. This scenario is impossible. But sometimes you do want to allow this to happen. So we haven't used this word yet, but there are services out there, servers that people run that are web APIs that are sort of like freely available that anyone can make a request to. The New York Times, for example, going all the way back to what we talked about 2 weeks ago, like that New York Times exercise we're going to start thinking about later this week. That's an example where New York Times has a server. They want to allow anyone on the web to make requests to their server by design. Like they have a freely open and accessible server. And if they didn't allow anyone to access it, that kind of defeats the whole purpose of why they're hosting it. Like they're hosting it so other people can get access to what they're providing. So they need a way to sort of be like, actually, like we understand that this whole CSRF thing is critical and bad, but like in this case, for our server, actually, it's perfectly okay. We've like taken it into account. We've done all the security stuff. We're fine with it. We're fine if you make cross-origin requests to us. So this is sort of what CORS does. CORS is a sort of a procedure that a web browser follows when it needs to make a cross-origin request to ensure that where it is making the request to, it is an okay place for it to make a request to. So in other words, so that it can make a request to like the New York Times, but it can't make a request to something like Gmail, which is like much more locked down and private. So the way it does this is using what's called a pre-flight request. So way back 2 weeks ago, we talked about all the methods that are used when you're making requests, and we talked about a few of them. The two we've mostly used so far have been get and post. We've also touched a little bit on like put and delete here and there. I mean, I just talked about delete in the previous example. And we're going to talk about them more later this week. But there's another method that's sort of like really important in the context of CORS, and it is the options method, all uppercase options. What this is used for is when you want to make a cross-origin request from a web browser. So, I mean, first, what the web browser does, it looks at the request you're trying to make and does all its rules. It's like, oh, okay, this is the domain doesn't match. So it determines, okay, this is a cross-origin request. If it is a cross-origin request, then what it will do is it will send what's called a pre-flight request before it actually makes the real request. So a pre-flight request is a request made to the same URL with the method of that request being options, not get or post or put or whatever. The request is options. And then as request headers, this is why we're talking about today, there's some interesting headers involved. In the request headers that are made in that pre-flight request, you have a bunch of headers that start with access control. So I'm going to make a request here in a second. We can take a little look at a little bit of what that looks like. But some examples of the kinds of headers that you might see. Access control allow header, or wait, it's access. Oh gosh, I don't even remember what it is. Oh, that's bad. Okay, I'm gonna look it up real quick because I want to make sure I say this right. CORS access control method header. Yeah, here we go. So there's this header, access control request method, that's included when you make a pre-flight request. And the reason why it's included is because the method is now options. So it has to put that method somewhere so the server can know about it in that pre-flight request. So that method actually goes in the access control request method header. It's also some other stuff too, like, for example, if you're making a request to a server that's cross-origin, and you've got a bunch of custom headers in there, it'll also enumerate all those so the server knows what headers you want to include. So on the server's end, it now received this pre-flight request, and it knows, okay, this is the request that the client wants to make to me. And what the server does with this pre-flight request, it looks at all these details, and it effectively is like, does this seem valid? Like, does this seem okay? Or does this seem suspicious in some way? So an example of where it could be suspicious is, let's say the client wants to send a bunch of extra headers, or the client doesn't want to send enough headers, or the client's using like the wrong method. Well, what will happen is if the server's like, no, I don't want to respond to this request, then what it can do is it can respond with a non-200 status code. And what will happen is if you send a pre-flight request and, oh, access control request method was right there. I can't believe I just overlooked that. That's really bad. But if the server sends back like a 400 or something like that, then the browser's just like, okay, you're not allowed to make that request. And that is when you see this error or something like this error. In this case, it's actually, I think that that's not sending anything back. So it like made a request. It was just like, nope. Like I think maybe it either sent back a 404 or just like terminated the TCP socket or something like that. But like you'll see some sort of like that sort of error. What that means is the response that came back from the pre-flight was not up to par. Okay, so let's go down the other path. Like, let's assume the pre-flight request works. So everything goes well. The server looks at the pre-flight request and it says, oh, this looks good. And then it sends back in response to that pre-flight request a 200. The client receives that and it says, oh, okay, I can make this cross-origin request. And then at that point, the request just continues normally. So it continues like with all, like it's allowed, it makes the request, everything goes great. So let's do a little example here. I've got a couple fetches. I'm just going to copy and paste. Okay. So I've got example.com, and I'm including this extra custom header here in this request. And what you'll see is says has been blocked by CORS policy. Response to pre-flight request doesn't pass access control check. No access control allowed. All this stuff. And the reason why, I oh wow, Chrome's changed a little bit since I dug deeply into this. That's interesting. Didn't actually used to say CORS error there before. So I guess I'm not gonna be able to show you actually the option. Oh wait, is that why? Oh yeah, there we go. Cool, that's what I was looking for. So what'll happen here is yeah, okay, here we go. So I make this fetch here. So this is sort of like the request that I kicked off. Actually, maybe even the better way to do that. Let me clear it and let me go like this. There we go. Okay. So try to make this request. It noticed, oh, example.com, that doesn't match queries to code.xyz. So this is a cross-origin request. So what it did is it kicked off this pre-flight request. This is the request URL. Options is with the request method. And then a bunch of request headers. So there's our access control request method. It'll also give you a list of all the headers that were specified. So like x hello is what I put here. You can see that the server didn't return a response. So because it didn't get anything back, like it was invalid. It was like, okay, well then I'm not letting you make that. And it says the original request here under status, it just says CORS error. And it sort of gives you this error here, enumerating it a bit more. One other thing I do want to mention. So in the response to a CORS request, one thing you also have to specify as a requirement is a header called access control allow origin. That's what this is about. So what this allows you to do is in the response back, you can sort of say like, only people who are on this domain name, like in their web browser right now, are allowed to make this request. So imagine I make this cross-origin request here and I make my pre-flight request. And in the response, I get access control allow origin. And then the value is something like google.com. What that'll mean is if I'm on google.com, the server's allowing me to make a cross-origin request to it. But if I'm cruising code.xyz, I can't make that cross-origin request. So using that header and a bunch of these other sort of access control headers you can return back in the pre-flight response, you can sort of dictate to the browser where cross-origin requests can come from. And this is sort of where the security comes back in, where this is how you can sort of lock down where requests are going to come at you from to sort of keep like the sort of like in the Gmail example, to keep like some external party from issuing a CSRF against you. Okay. So one other quick example here. We're going to use the GitHub API later this week for some stuff. But I'm going to make a request to it just to at the root api.github.com. And I'm going to make this request with, again, a custom header. So the reason why I'm doing this is a good example of an actual pre-flight coming back from a real API. We can take a look at it. So in this case, we got back sent an options. We got back a 204. 204 is sort of like fancy code for it's a 200, but just there's no body content. So some servers will choose to send back a 204 instead of a 200 with no body. Okay. So in here, in our response headers, you'll see we've got a couple interesting things. So access control allow methods. So what this is saying is if you make a request to this, to api.github.com, you can make it with a get, a post, patch, put, or delete. Access control allow origin star means you can send a request from anywhere. api.github.com, this is a public API, so they want you to allow you to send requests from anywhere. And then, where is it? Yes, here it is. So access control exposed headers, I believe. This is saying what headers you can include when you make your request. So this is like sort of like an allow list of all possible headers you can include. And notice X hello isn't anywhere in this list. So because of that, I mean, this error kind of reads pretty well. Request header field X hello is not allowed by access control. Oh, allow headers. Yeah, I was on the wrong one. Okay, access control allow headers, not expose headers. It's not allowed by this. So what happens is the pre-flight request, like you sent back the response, and the browser was like, I can't make that request. So I'm going to do this again. Only this time I'm going to get rid of the second parameter. And what you're going to see is this time it works. So we get the sort of the 200 back here. I'm pretty sure I remember running this last time that Chrome doesn't show pre-flight requests that are successful, because otherwise it would just like clutter up your developer tools thing. So they choose to hide them, which is a little confusing in this case, but it is happening behind the scenes. It's just because it didn't go wrong, you're just not exposing it. Okay, so that is sort of high level what's going on with course. So to sort of, I've got some diagrams here just to quickly run through. I probably should have had these up as I was talking. So when you make a cross-origin request, it'll issue a pre-flight request to your cross-origin domain name. And if it sends back a 200 with access control allow origin mapped to your domain name or star and all the other access control allow origin headers set right, then the pre-flight request was successful. So now it'll make the actual request. And same sort of thing, if the pre-flight request comes back and fails, then it's just going to stop the request. You're going to get an error. Okay, so why do, like, if you hear me say this probably doesn't seem like crazy complicated. I mean, it's a little complicated, but like after me walking you through that, I'm guessing you can probably like kind of reason your way through it. Why do I say that cores is just such a pain to work with? The reason why is cores is there's a lot of sort of weird like exceptions with cores. I sort of gave you the like, imagine if you followed all the rules kind of way of thinking about it. Like, but there's a lot of sort of weird exceptions, mostly for backwards compatibility, because cores wasn't a thing when the web first came around. It was sort of like hacked in later. Because what ended up happening is like these sort of like issues like CSRF and other things like that were kind of discovered later. And people were like, oh crap, we got to figure out how to fix this. And cores was sort of one of a few solutions that came about. So one exception is just like an example it's worth knowing about. There are certain sets of headers, a minimal set of headers that you can include, or okay, I guess I should say like if you make a cross-origin request and you include only a few headers that are special ones in a special list, you don't have to make a pre-flight request. It will just always work, a cross-origin request. Well, I guess I shouldn't say always work. That sounds like I'm really sure of myself. It should work. But like this is like one of those things where the reason why this was done, yeah, here we go. So if you want a simple request, either has to be one of these methods, can only use these headers, can only be of one of these content types, and there's a few other kind of lesser important details. But like, it's sort of like if you thread that needle perfectly, then you don't have to worry about cores, which can sometimes be helpful. But you have to sort of like play trial and error because you might not get it quite right on the client side. You have to fix that. And then when you try to make and process the pre-flight request on the server side, it might get it a little bit wrong. And it's one of those things where unless it's all perfect, all the sort of steps all work exactly perfectly, it's going to not allow you to make the request. So you end up banging your head against the wall, being like, why won't this thing work? And whenever you're sort of building any new web API service from scratch, like it is at least a day of just like getting cores to work right, especially if you're working in like new tools you've never worked in before. It is incredibly frustrating. So this is all to say, cores is complex, it's complicated. Um, I'm not going to be able to give you sort of a like perfect guide on how to make it work. Mostly, I want to expose you to it so you know that it's a thing. When you see like one of those access control out origin header types of errors, you'll know, oh, this is a course thing, and you'll sort of be able to start to launch off and do some of your own research with sort of some terms in your back pocket. Um, so I have linked a pretty good guide written by Auth0, which is a popular sort of auth service out there, about how CORS works. If you want a bit of a deeper dive and want to go through like some of those weird edge cases I didn't cover, it's a pretty good read, but definitely not a requirement. Okay. So really my takeaway for you from all this is CORS exists. It implements some complicated rules around cross-origin requests. If you have to make cross-origin requests in your web app, it's going to be frustrating. And it's just how it is. um, okay. So that's all I have for you today. I do just want to throw out there, anybody have any questions about CORS? I'd love to do an exercise with you on it, but it's kind of hard to do that because we don't really have like a bunch of API services under our belt to like work with. So tomorrow we'll start to actually learn some important stuff so we can work with some real API services. And then probably on Wednesday, we'll be actually like making some real requests. That'll be exciting. But any questions anybody has? Okay. So tomorrow we're going to be talking about JSON, which is going to be a lot of fun. And is very important. Okay, so I think we're gonna be. I mean, I went kind of late every time 2 weeks ago, so I guess it's probably good. I'm actually ending. Oh yeah, wait, off tomorrow. Oh yeah, open hack. That's right. Yeah, Max did want you all to go, so I guess you are off. Huh? I didn't realize that. Thanks for bringing that up. Yeah, go to open hack. I'd be there, but I don't live in Syracuse anymore, so I'm whenever I'm in Syracuse, I try to make it line up and try to make an appearance. So maybe I'll see all of you there at some point, but won't be there tomorrow. Yeah, cool. So sounds like you're all going to open hack tomorrow. I got the night off, which is exciting. And I'll see you all on Wednesday. So I guess we're doing JSON on Wednesday. Cool. Well, if nobody has any other questions, have a good evening and see you tomorrow. Bye, folks.